So hi everybody and welcome back to C++ Thursdays for Absolute Beginners. This is video 299, and in this video we continue with our value categories, and we are going from here C++11, and we talked already about has identity and can be moved from, but we have not clarified what it means can be moved from, and that is what we are talking in this video. And again, these two properties are very important because they are defining the values. For example, here an L value is defined how? With the property identity and moved, and then that's why we have to understand both properties. And let's get started. For this purpose I have Paint here again and try to make an example what it means now move. So what means can be moved, but before we jump into move I make an example what it means just that what we already know, what means copy, and then I show you the other thing what it means move. And you can see here I took here this int c, copied it here, and then I made here a memory. This square should represent a memory location, and this is a memory address below, and the number here in it is the value of seed, so it's the value of this memory address. And the C, you can see, is the identifier. Important is here the C is also the owner of this memory address, so ownership. So the C is associated with this memory address, and it's also called the owner. That's also very important later a little bit. Okay, with that said, I'm now, that is my first step. Let's write here a 1. And now I go to my second step. It's here. And here you can see I just create a new variable d. And here what I'm going to do is, you can see it, I try to assign the variable c here to d. And when we are doing that, what happens? That's very important that we try to understand the process, what happens. I make, of course, all this kind of stuff, what I explain here is very simplified, but let's see it. So that you can understand it also very fast. So, so what happens here is this assignment operator says, okay, I check C out, and how it checks, it goes to the memory location, and then what the assignment operator finds is the value, and the value will be what? Will be taken or read. It is just read, and that's very important here. The assignment operator is just reading this one. After the assignment operator reads this value, then it creates a copy of this value here. So the assignment operator goes here to this memory address and is not taking this value. It is still here, it is just reading it, make a copy, and this copy is then temporary because this is the compiler is doing this one. And then this temporary value, which is a copy of this memory address here, is then assigned to D. And important is here, this D here, when we watch the below memory address, because D is again the owner of a new memory address, and we are copied, or let's say it's called here assigned, here the value in. But important is the process. What we do here is reading this value and then creating this value and then putting it here, this new temporary value. So it is not taking this value out from this memory address, it's still here, and we are putting it here. So I hope that's not too difficult, because that is what we already should know by now. And now comes the third step. And now I try to make a move, but I don't explain it with the right symbols here. Careful about this one. This is just to try to understand what the move would try. Not it is making like this. Later we go later in real syntax, but what it means move. So again, I start again with a int type like all the other one. Again, a variable name. Of course, they are super bad names here. You can see all these names are very bad, by the way. Never code like this, you will be kicked, by the way. Here read this comment. It says here, never use variable like that for real programming. A bad style, you get fired, or nobody will read your code. But in this case, it's just a demonstration. Again, for demonstration purposes, they are doing this one, and in this case, I do it too. But never do it in real programming, please. All right, with that said, so here again, m is just a variable name, and here I try, like here in number 2, assign the value c to m. But this time I want mega move semantic. So what I want moved here, that what is in C to M. What happens there? So let's say it's not an assignment operator, then it's a move semantic. Let's call it move semantics. Will go here again to this address of C because we want it from C, right? And then it says, okay, I see your value, but I'm not interested in your value. I'm interested in your owner, and the owner is here C. So this move semantics is interested in this owner. Why it is interested in this owner? Because move semantic means I will not make here a copy of this value here, and I won't use your memory address because that's the purpose of move semantics. You want not lost performance. You want just use that what the yeah, the moved object got. You want just own it. So again, I repeat, the m here, the m, when we try to move it from C to M, the move semantic goes here to this memory address. It's not interested in this memory address itself because that should stay like it is. It is just interested in C, and then this move semantic will change the owner here. So it will say, hey, I am the new owner. You get deleted. Oh, not deleted, it's still valid, sorry. It's not deleted. Also, it's still there. But this memory address here, let's make it so. This memory address here belongs to me. And don't ask me the technical things here because normally that's a little bit more complicated. But this is just the meaning of, move semantics. Move semantics say, I'm now the owner of this one here, and you are just you are still there perhaps, but in an invalid state. Of course, all this kind of stuff is very complicated in detail, and you can already see when you make something like this one, perhaps this one has also a memory address, what happens then with that, and so on. So it's a little bit more complicated, but here I want to just show you the move semantics in a very simplified way. And yeah, if you understand this, then you understand move semantics, because that's it. So again, in a very super simple way, move semantics means just don't make a copy here. That's very important. Don't make here a copy of this value, and instead use the memory location with the value here, and that will give you the performance boost, because you are not creating new things. And with other words, you will see you are not using copy like here, because this assignment operator says I will copy this one here and I have it here down. So if you understand this one, very good. It's just this ownership, because this move semantics means I become the owner of your memory address with your value. So there is nothing, not so much changed, and this not so much changing will give us later a very high performance boost, because think about again, not with this primitive types, because the primitive types, even if you would make a copy, would still okay with performance. But think about it with custom types. For example, if you create a class and your class has many datas in it, and you have not to, I don't think it's possible, but let's say, think about it, this kind of stuff will be just not copied. That's the point. And yeah, more or less, there is nothing much to tell actually. If you understand, you just change here the owner and you get all the benefit from not copying all the values what's in there in this memory location, and that's the whole boost what you get. Very simplified. Of course, you can watch this in detail later, and it's not so easy. There are still many things to understand, like I said, but if you understand that, very good. But we can talk about one more thing here. And the thing is, why is this not allowed? Because what I showed you here is normally not allowed. I say normally, we have to talk about this later why I say normally. But this one, the C here, right? This one is an L value. Yeah? And an L value you should not move, right? That was one of this. Let's go to the diagram here. I showed you here the diagram because later we will go here and discuss this a little bit more in detail. But you can see here the value, GL value is the whole thing, but the L value here on top is just this square. It says here can't move. And the question is now, when we watch that, what I showed you here, why it should not be able to move? I mean, you see, I changed just the ownership here with int m equals c, and that looks very easy, and actually it's very easy theoretical, and there is no problem, right? Think a little bit about this one, and you can stop the video because now I will say it in a very short form, not in a detailed form. And now I say the answer. The answer is, actually in theory you can make this. There's no problem. But practical, this will cause a big problem because this value, L value, it's like I said, the C here in my program, right? The problem is, how many times is the C here reference? For example, I'm referencing it here with a pointer, and before it comes to the place where I'm moving it, let's say there is code between this one. Let's make it so. For example, let's say here is 1000 line of code, who is referencing perhaps the C, whatever you want to use. And then you are trying to take these resources from this one, and you would cause a very big problem for the code between if this one is an L value, because L value means again, what means again? It has a location like here. A location means it can be referenced. Yes, we can make 1000 reference. I make here between 1000 references. And then when I try to move now, and we know, I hope you know what moves means. Let's say I just change here the owner, then all the references will have here a problem because, or let's say can cause a problem if it's not handled. And the easy answer is then what they made is they said, we are not allowing just that you are moving from L values, because there are not only this problem, there are a million other problems as well: security, readability, safety, and all this problems which I have not discussed here. But of course, when you go dive into this one, you will see there are many problems, but like I said, theoretical, no problem. Practical, not good. You will have big problems. All right, I think I talked again here too much, and again, you have to read a good book for this one. But if you understand this one, that is very good. Then we will discuss in the next time this diagram, because we have now clarified a little bit these two important properties, identity and can't move, but we have not clarified it what it means can't move in x can move x value. We have a little bit, L value, I showed you, I explained a little bit what it means. It can't be moved because there cause problems, but here the question is, wait a minute, there are some L values which we can move, and this one I have to explain you again, because these are again special cases, and then we will also cover x value, what x value means. And again, try to read this in our book a little bit more in detail, and all this kind of stuff we are doing just because this value categories, that you don't get confused in the future. This will come up in some places, and then you know at least basics. And again, this is just very short. I will later link, when I finish this one, CPP reference presentations from other people, from official, from good people, and they will explain all this kind of stuff again. But of course, it's nice that we have covered here some basics, and then you can understand what they are talking as well in much better. All right, with that said, if you have any questions, like all time, write in the comment section. See you in the next video. Bye, good luck, and like all time, have fun and never give up.